Okay, so here let's talk about some aspects of this study and really whatever comments y'all have. So here, the combined effects of soy isoflavones and milk basic protein on bone mineral density in hind limb unloaded mice. So right there, that already kind of tells us everything that we're looking at in the study. So like, hopefully you read this because how many questions could you have answered just from reading this? Yeah, like at least one or two potentially, right? So here, let's look at this. The purpose of the study, like what's the whole idea behind this? Whenever we're looking at bone loss, there actually are studies where people are paid for bed rest or like go up really high into like space and things. However, this is somewhat cost prohibitive putting someone into space, right? Like rockets cost a lot of money, and bed rest isn't exactly the same as what it's like to completely be losing the whole estrogen signal of bone, like bone reformation, or going up into space, right? So that's why we use animal models to test things that are fairly difficult for us to do, like in real life humans. Does this make sense to everybody? So right here, the idea is like we examined whether the combination of isoflavone and milk basic protein both are reported to be effective for bone metabolism, prevents bone loss induced by skeletal hind limb unloading in mice. So right there, that's already kind of telling us everything that they're looking at. So previous studies looked at just the soy isoflavones or the kind of like estrogen analogs. That's already been done. And looking at milk basic protein, that's already been done. Now they're looking at the combination. So the idea is if we have a particular individual, can we make some type of like protein drink mix to have both of these things in there, and would it have somewhat of a cooperative or additive effect? Later on they said that, right? Is everyone good with this? This makes sense? Like this is the whole rationale for doing this study. So what are we saying right there? Okay. Um, I really just highlighted this to show you like the different like types of things that they're different human populations that they're doing this actually for. Because like a lot of animal research has virtually no purpose to it. However, this one actually does have quite a bit of purpose. So good, interesting, right? Spaceflight, osteoporotic. So that's really what all of this comes from. All right. And then at the very end, the combination of the like ISO, essentially the soy, and the milk basic protein and hindland unloaded model hasn't been fully understood. So that's really what this study is doing. It's filling that research gap. So other research hasn't filled that yet. Is everyone good with this? Now, like it seems really arbitrary, but that's because most research is trying to fill a fairly small hole that a lot of people don't even know is there. Right? We good with this? Right? Okay, moving on. So the materials and methods. So this is what hind limb unloading looks like. Like, did anyone Google it before? No? Really? Because like this is like the second picture that comes up from it, like whenever you do it, right? So it's I don't know. Google's pretty awesome. So the idea here is you attach a mouse's tail to like this suspension device, and they effectively are not using that part of their body, right? So that's somewhat simulating like anti-gravity or like not being in gravity. What's up, Eric?
Can they only walk in a straight line?
Oh no, no, no. Like this thing, it's frequently like it has like different parameters to where you can go like all around inside of it.
What
So
about track kind of thing?
yeah. It's yeah. The only thing that I've seen, I don't think they can really walk in diagonals. You know, like along the cage. It's but like something to keep in mind, like mice are really small, so like you can have a fairly small cage, and and they frequently do, so they run back and forth all the time. Now a problem here is that being hooked up to this, they can't be in a running wheel, right? But like that's actually partially what they're trying to simulate is like not having any like muscle tension or anything like that. Now something I wanted to point out, and I wouldn't expect anyone to understand this. Yeah, like would they get super jacked right there? Not really. So like it makes sense that they would, but what I found, like whenever I've been around people doing this, they end up just moving a lot less. Like if you actually track their movement, like compared to an animal that doesn't have a running wheel, but like can move around in their cage, they just move a lot less. They nap a lot more and just eat, basically. Um, now, this part, the strain of mouse. Now, here's a big thing. So it's a typical white laboratory mouse, like Pinky and the Brain, right? Everyone good with this? However, different mice are bred for different things. So this one is actually the most commonly used laboratory mouse in Japan, which that's where this study was done. DDY. So what that means, DDY. So Deutschland, Decken, and Jochen. So it was actually they figured it out in Germany. Yes, that's what Deutschland means, right? So, what?
Those 3 words are
Oh, yeah, right. So, like, why would we listen to them? They only lose world wars. So, like, right? Perfect. But, like, they're actually fairly good at science, I guess. It's in Volkswagen. However, those are overly priced. But you can look up different things about the particular strains. Some are bred to be obese. Others are bred to have epilepsy. Others are bred to have this, that, or the other thing. You can really just selectively breed different ones that have particular conditions so that a scientist could look at a given condition. So the reason I'm bringing this up is it's inbred, which don't think anything about that. All of these mice and rats are inbred. Strain DDY was developed like from an outbred DD, so like apparently Jochen wasn't a thing. Germany transferred to Japan in 1920. Now this is the part. It shares 75% homology with an epilepsy model. So epilepsy, does everyone know what epilepsy is? Like vaguely, right? Like seizures and things. So do you think this could be confounding at all? Right? Maybe. Like, we don't know. I don't know exactly. But there could be some type of interaction that stimulates seizures in like an epileptic model that would have some downstream effect on bone reabsorption or bone formation. Does this make sense to everybody? Like what's the biggest mineral for your bones? Calcium, right? That's also a cell signal for numerous things in the nervous system, right? So if there's something wonky in calcium metabolism in your brain, those genes are expressed differentially throughout the body, so there could be something crazy going on in the like bone as well, right? Right? Now, I wouldn't expect y'all to get any of that just from reading this, but whenever you're reading research, you have to pay attention to crap like that. Like one thing, for example, and like I'll just share this a little bit of a story just because this happens to me all the time. So I think all of y'all know that like I've studied the ketogenic diet for a super long time, like Atkins diet, that type of stuff, right? So I mostly did it in humans and rats. Anytime there's a study where the ketogenic diet is done in mice, it is done terribly, and they always respond bad. So if you ever read like a headline saying the ketogenic diet was bad for X or Y reason, it is most likely citing a study that was done in mice, because the particular strain of laboratory mouse that is used in the United States does not oxidize fat very well because there's this mutation in their mitochondria, right? Does this, like, is that weird to anybody? And like I would talk to people at conferences and they'd be like, oh yeah, keto is crap because I use this mouse model. And I was just like, well, you're stupid, right? Like you use the wrong model, right? So whenever you're using animal models, you have to be aware of all these different possible interactions. So I use this study to like try to get you an appreciation for that. Is everyone good with this? Right? Okay. So, all right, moving on from there. And hind limb unloading, that's what it looks like. Another thing. Is that like spaceflight? No, totally not. Like now it's simulating a very odd like aspect of spaceflight, like unloading these hind limbs. So like that's a cool thing. But if anybody has taken like my Phys of X class, we have things called myokines, like they're secreted from your muscles that are actually contracting. So kind of like what you were talking about, these muscles contracting up here, they're going to send a signal systemically throughout the body that there might be a bit of a difference compared to this versus being in space. Well, like here's an example really quick. Has anyone ever broken their arm? Okay, just y'all are metal. Cool, good. So if you've broken your arm, there's actually research indicating if you exercise your other arm a lot, you lose less muscle mass on your broken arm. Right? Yeah, like contralateral signaling. Super weird, but that happens. So would it make sense that like this guy isn't just floating in space, right? So there, keep in mind, you can critique a study on numerous levels, and like that's really just what I'm doing. Now, this is a super accepted model, and I don't really have any problems with the study outside of that. Cool? Everyone good with this? Make sense? All right. Man, I talk entirely too long. So what did they do? It was approximately a 3-week study. There was a normal group, which effectively was a control. There was a loaded group, which they actually didn't explain that very well as to like what was really happening in there. So I'm not really sure how they do a loaded mouse. It's like do they put a weight vest on them, right? Now, like there actually are things where you can do stuff like that, but that seems very cumbersome. Then like an unloaded control and unloaded ISO with particular levels of like this food, which is essentially just the soy, and then milk basic protein, and then both of them mixed together in some way. And then they looked at weight, femur, and some genes related to bones. So this effectively is what happened. This, bless you, this was one of the questions. So normal loading, the weight in grams over the course of this, and then all of these experimental groups, like the unloading control and the ISO and milk basic protein and then the combination thereof, they all lost weight. So they did have a weight loss in all of these groups because they're not using those muscles, right? If you don't use it, you lose it. This makes sense to everybody? Right? And then the compensatory like muscle gain in their upper body probably wasn't enough to really increase this too much. And just something to keep in mind is that a mouse, approximately adultish, weighs around 30 grams. So if they're losing like 3 grams, that's 10% of their body weight. If they're losing around 6 grams, which most of them seem to get close to, that's 20% of their body weight. So this is a pretty significant weight loss, right? Like, can any of you imagine losing 20% of your body weight here in like 3 weeks? You have a bunch of tapeworms, right? I think that would be the only way that would even be possible. There with that. Here, they were looking at bone mineral density, and really all I'm trying to show, they talked about some fairly interesting interactions between the different like ISO and milk basic protein, but really, I don't think you need to do any statistics to understand this. So overall, normal, loading, unloading, control, what did all of these do? The unloaded ISO, unloaded milk basic protein, and the combination of milk basic protein and ISO. What did that do for the whole femur? Here's phrasing that I want you to know. What these different supplements did, it rescued the loss of bone mineral density that would have been present in the unloaded control. So if they wouldn't have drank those or had that within their feed, then they would have been there. So it essentially brought them almost on par with normal and loaded. Does this make sense? Right? So an unloaded bone, you give them these drinks, and then the femur essentially maintains its density. So that's really good for osteoporosis and being in space, right? Because you don't want your bones to be super brittle in those cases. Effectively, the same thing happened at the distal femur. Hopefully that's interesting to everybody, right? No, is this not interesting to anybody? Okay. So what are the applications of this? Like, let's just think about it. Anything. Or did all of this research just waste money? It did not waste money. Why did it not waste money? Or maybe it did. I mean, mice are actually pretty cheap, so like it's whatever. You know, I can just find them, right? Yes, Sophia. Yeah.
protein
Yeah.
into your diet so that their bones stay strong.
Yeah, totally. What's up, Trent?
Yeah, you can say the same thing about the astronauts are going to be using this. Now
Yeah.
NASA can use this, and they can make sure their astronauts' bones
Yeah.
are brittle.
NASA or SpaceX or any postmenopausal women, like if they start supplementing with like these types of different things, it's like, okay, like if you're going up to space or you're not having estrogen anymore, this might prevent some like of the complications of losing your bone, right? Like, doesn't this make sense to everybody? Right? Like that's really what this is. Then we would have to translate this and actually try it in humans and like potentially different models, like say a rat model or a chimpanzee model or whatever, to see if it's actually conferring a benefit. Because if it works in mice, it'll probably work in people, but not always, right? So this is essentially a first step in many. Hopefully that makes sense. Okay, the genes, I'm not going to talk about that because there was actually like a differential effect in the genes that was pretty cool, like with mRNA expression of like alkaline phosphatase with the milk basic protein. But like you can read that if you want to. Okay, so the point of all this, really, I think this sums it up. As a result, we suggest that milk basic protein prevents unloading induced bone loss by normalizing the bone remodeling balance. These results suggest that the combination of soy iso and milk basic protein may be useful for bone health in subjects with disabling conditions as well as astronauts. So this is essentially what Trent and Sophia said. That's really the point of that whole study, right? And like there's a bunch of busyness within the method section that you don't really need to understand to get the take-home points of this. Is everyone good with that? That makes sense? Okay, cool. So back to the hierarchy of evidence type of stuff. Approximately like where we left off last time, and I'm going to try to go through this really like as fast as I possibly can. So whenever you look at a meta-analysis, so this is an example of a meta-analysis. And here are the forest plots. So that's Sina 2009 study, males and females. The idea here, processed red meat, things like that, or like unprocessed or even processed red meat, increases your risk of death in all sorts of different conditions. So let's go through this together. The milk intake and mortality, this study, that's the Sina 2009 C. Rashimi Sina, right there, PhD, super intelligent person. This is the conclusion that they came to, and this is what I asked y'all before. Like red and processed meat intakes were associated with a modest increase in total mortality, so just meaning dying of anything. Cancer mortality and cardiovascular disease mortality, so getting cancer and getting heart disease, like a heart attack, like whatever, right? So right there, does everyone agree with that as it is right there? Hopefully. Hopefully you agree with that. At least hopefully that's kind of what you think. And if you've been listening in other classes, this is what they say. Like saturated fat's bad for you, cholesterol's bad for you, all of that type of stuff, right? Right? Bad, so-called, right? Okay, cool. So like let's move on. This at 1 hour, 4 minutes, 40 seconds, the Gamechangers documentary, which I wish more of you watched because this would be very funny. This documentary is probably like one of the biggest things in nutrition right now. So this is as topical as it gets, right? Because I have nothing better to do with my time. Cool? Right? So they, James Wilkes, the guy who put this documentary together, he's citing this study, talking about the overwhelming amount of scientific evidence that animal foods are bad for you and they cause death, right? Everyone good with this? Right? Okay, like I could talk about it more. He talked about industry funding later on, but whatever. So here, this is actually from that Sina 2009 study. And this is men, quintile, meaning red meat intake, lowest, not lowest, middle, almost highest, highest. So I had a bunch of people. Oh, yeah. Yes, yeah. No, I totally know. Like this was the slide that we finished on. Yeah, like no. Well, like it will show up here in a bit. Like, oh no. I know. I'm just reminding you, man. Jeez. Oh no, like hey, all time's wasted time. But like whatever. Well, I mean, like, I have no commentary about that right now. Okay, so here. That number, 6,000, 13,000. Right there, almost 2,000, almost 4,000. Right? So all of us were agreeing with this so far. Like here, I believe this is closer to where I stopped last time, where the mortality from injuries and sudden deaths, that's effectively car accidents or falling off ladders and things. What is it about eating a steak that makes you fall off more ladders? Does it impact your, like, does it give you like ataxia or like your brain isn't working very well? Anybody? No, there's no relationship there. So like maybe that could be a thing. Now here, if we look at this, this is how it could be reported. 107% increase. So if you do the math right there, that is 107% higher than that number, right? And the reason I'm doing this, this is called a relative risk. I want you to know relative risk doesn't really mean anything. That's why I'm doing this. 108 for cancer mortality, 98 for cardiovascular mortality, 86% for injuries and sudden deaths. And then lastly, down here, all other deaths, what does that even mean? You know, 134%. So effectively, all of those numbers are approximately the same. Can we agree with that? Like it's all like 80 or above, right? So if you ever hear there's a 100% increase in risk from something, keep in mind that eating red meat makes it to where there is almost a 90% increase in you getting in a car accident, right? Most things are dumb, right? Cool. It's like, yeah, like me. Okay, now women, I haven't like, this study isn't dumb. I'm about to show you something cool with it.
Oh, really?
Right? Oh, totally. Okay.
Razzle-dazzle.
Well, hey, you're a woman, right?
I mean, I think so.
Okay, so here, let's check this out. So women, same thing. Quintile 1, 5. All right, check this out. All-cause mortality, 5,000 down to 3,700. So eating more red meat, less death right there. So have a steak tonight. Maybe? Good, good, good. Okay, here, cancer mortality, 2,000 to 1,300. Do y'all see how this is going down now? Right? Okay, check this out. Down here, like injuries and sudden death or whatever, 129 to 61. Now this is interesting. Women get in less car accidents or do like less BMX tricks than men do. So like that's fairly interesting to me. So that went down. So here, decrease in about 30%, decrease in 37%, decrease in 23%, decrease in 53%, decrease in 28%. So the biggest percent decrease is dying in car accidents for women who eat more red meat, right? Is this confusing? No. Now, so it should be confusing if you have a working framework of how health works. But like, yeah, that's no, that's okay. That's okay. So here, like, let's look at this. Let's look. So looking at different things, what are some confounding variables that might cause someone to die from anything? So that's cardiovascular disease mortality. So that's so exercise, smoking, eating fruits and vegetables, all that stuff should be related to it, right? So here, let's look for the men. So right here, that's smoking, and the quintiles 4.9, whatever number that means, up to 14.8. So right there, that's about a 3 times increase, so a 300% increase in amount of smoking for the people who consume the most red meat. Do we think that that might have an effect on dying? Right? So like keep in mind, men over here died way more than men over here. Everyone good with that? Okay, now here for physical activity, 30.7 down to 16.3. So half, cut that in about half, right? So they exercise half as much, bless you. Do we think that that might have an impact? Right, okay, cool. So like moving on to the women. Everything with the men should have made sense. Now with the women, keep in mind, here's quintile 1, here's quintile 5, right? So they died the least, they died the most. Good with me so far? Okay, let's look at the same things. So here, smoking, 8.8, 21.2. So women who ate the most red meat and smoked the most cigarettes died the least in this study. Right?
It's pretty sick. Not
Yeah, super metal, right? Yeah, yes. That is, I believe it is a
Smoke 2 packs a day. If you really wanted to.
I'd have to go back and look. I'm fairly sure it's a percentage of the whole of like that many like 250,000 people. So like 21% of them like smoked or current smoker having quit within a year prior. So 21% meet that criteria. Are you good with that?
So that's not saying how many deaths there were, those numbers?
No, the one before was saying how many deaths there were. Yeah, yeah. So this is just reporting on how much of them smoke. Right. So like 8%, 21%. Cool. Go with that. Right. All right. Next one. Like exercise, wherever that is. Vigorous physical activity, 22.5 to 11. So follow me. Again, for women who ate the most red meat, over here, smoked the most, highest percentage smokers, highest percentage of vigor or lowest percentage of vigorous physical activity had the lowest death rate. They didn't though. No, no. Well, like this type of data happens like quite a bit, right? So like the reason that I'm talking about this, if you read into meta-analysis, which is the very tip top of our hierarchy of evidence, you can't just take their word for it every time. Sometimes you have to go into the like studies that they cite and see if you come away with the same conclusions. Because like right now, that meta-analysis and this study said that eating red meat and processed meat is bad for you. Effectively, that's what it said. After going through the data, how do you feel about it?
It depends on if you're a man or not.
Oh, yeah, yeah. Like it certainly depends on if you're a man or a woman, but like, well, overall, it's just less clear, right? It's like I would not be able to definitively say that eating red meat or like, I don't know, ham sandwiches is bad for you.
It's just, yeah, it's just not like clear cut.
Yeah, yeah, yeah. Like it's very murky. It's very confusing, right? And that's that's effectively all that I wanted to say about that. Now, I'm going to go ahead and start talking about the dissection of an academic paper. I'm just going to get through like a slide or two, okay? Now I'm going to try to be teaching you a couple of things whenever we're going through this. So this, at the beginning of class on Wednesday, I'll tell you what day it's due. It's written on the syllabus. Does anybody have it written down? Oh, like it's okay. It's okay. It's not a huge deal. Not a huge deal. So dissection of an academic paper. So kind of what I've been doing in front of y'all. 19th of April? Oh, like it's definitely not February because that's my older brother's birthday and I would never have something to do on that day. Yeah. You know what? I actually think about stuff like that. Here, it doesn't matter. It doesn't matter. I'll look at it later. So dissection of an academic paper. This is a very important assignment that you're going to need to do. So what I'm doing in front of you, you're going to have to show to me that you can do it on like writing in a paper, right? So there's approximately 12 dimensions of analyzing a paper. And this is how this paper is going to be graded. How most of the time you write papers that are somewhat continuous, like one section flows into another section. I don't want you to write this paper like this. I want you to section it up into these 12 different sections and just have everything included in a particular section. Now, would it be cool if you picked a paper that was within whatever your group is studying? That would be cool. It doesn't have to be. Now, what I would like you to do is probably do some type of human experimental, like randomized control trial. Pick a paper that's something you're interested in and analyze it along these dimensions. Cool? So these dimensions, what they are, and I'll probably just read these to y'all because it looks like y'all are getting very bored. So who did it and when? And if you haven't read the CrossFit Keto paper yet, I'm going to do this for you. What has been done prior to this paper? That's going to be really important in knowing, really the answer there would be in the introduction section. What was missing in the current body of research prior to this paper, and effectively why they did that paper. So how I was pointing out, like in that animal study, why they were doing it, That's kind of what you need to do. Who did they perform the experimental intervention on, and who are the participants and their characteristics? So how I talked about like the mice, like different facts about the mice. I would also tell you like how much they weighed, like how old they were, different things like that. That'll be important. What was the intervention? Tell me what was happening in the experimental group and the control group. So effectively explaining the methodology. What happened in terms of the results? What was the magnitude of the results? So the magnitude of the results, that out of all of these, that's probably where I'm going to grade you the hardest, right? So whenever we were talking about that case report with that like old guy who went from like 2.2 miles per hour to 2.7 miles per hour, like his ability to walk for like 6 minutes straight, that's what I'm talking about. How much of a magnitude it is. So convert their metric system into our system, make it something that you can understand and explain and really like get. Does that make sense to everybody? Right? Like you need to do something that's tangible. So what is the internal validity? If you don't know what that is yet, I'm going to tell you later on. It's effectively how well they controlled everything in the study. What is the external validity? How well things are translatable into other scenarios. What are the limitations in terms of interpretation, application of this study? So there's frequently a limitation section. So like, what can you not do with the data from this study? So kind of like the animal trial. Well, like since they were just Heinlein unloaded and they weren't actually in space, I can't say with utter certainty that this is a great thing to do if you're going up to space, right? Like myokines and like also like they're still on the planet. Also they're mice, of course. Next thing, list the funding resources. Most of the time there are funding resources that are listed. And then lastly, what are your own biases? That one I essentially have to give to you. So like effectively, why are you interested in this? So next time on Wednesday, we'll start talking about like my paper. So like read that prior to next time, and we'll talk about different aspects of it. Cool? Good? All right.